Oh,
Itu validasi
PK.
PKKS.
Oh,
iya boleh tuh.
Ayo.
Iya, maksudnya kita menjadikan tabu itu kan biasanya itu lebih parah kalau orang-orang di lapangan tapi ada validasi baru kan. Jadi ada setiap validasi baru sekarang mereka di lapangan konsul pemerintah oh juga bisa sih ya baru tuh saya mendengarkan dan langsung saya
present my topic. I will be presenting my research about software engineering, and title is methods for software requirement volatility and anticipation. Thank you. Maybe Pak Anang, it's better if you sit in front of the audience. Yeah? Also for Bu Siti, you can sit in the front of you.
Yang persentase boleh bahasa Jepang.
Lagi itu. Ya benar.
Kita punya maksudnya ada ya.
Okay, Pak Anang will continue the presentation. Okay. Pak Monang, selamat pagi. Good morning. I will continue my presentation. I will present my one of my researches about my major is about software engineering, and the title today is methods for software requirement volatility analysis and anticipation. Before I begin to explain my research, I would like to show you about the research area in computing. According to the IEEE, the Institute for Electrical and Electronics Engineering, and the ACM, the Association for Computer Machinery, there is a computing curricula made in 2005, and it has been revised in 2013, I think, but there is no significant changes there. According to this computing curricula, there are 5 research area in computing. There are one about the computer engineering and information system, computer science, information technology, and software engineering. The first one, the computer engineering, is about how to develop an integrated system which use software and hardware. So it's about how to build an integrated system like a car, which a mechanic and also have some processing like control unit. Also for the home applicant like refrigerator, microwave, something like that, that mostly today use some kind of computing. The expert or the researcher doing in this area is called a computer engineer. And the second one is the information system. It's about how to analyze the requirements from the customer and how to proceed the the development of the system information system by doing some analysis in business process of their business. And the material in this area is has been taken by in the one of the course in this SDS, which is called the Analysis dan Perancangan Sistem Informasi. The expert and the researcher in this area is called system analyst. The third one is the computer science. This area is talking about the computing concept and software development. Mainly in this area is talking about how computer is thinking, how computer is process the calculation, how the central processing unit is understanding the programming language written by human. Something like that. It's mainly about that. It's about digital, how digital work in the computing area. The expert in this area is called computer scientist. And the fourth one is the information technology. It's about the infrastructure of the information technology and how to develop and how to manage this infrastructure. It's not just about the computer network. It's also about the communication network. Now we are using the 4G technology. Before is the 3G technology. That technology also studied in this area. So the expert in this area is called the network engineer. And the last one is the software engineering. This area is relative new in the computing area, but it still being researched and studied by most of the experts in this area. This area is studied about the software development and management, especially in the process and the phases in the software development life cycle. So in this area, expert in this area is try to find some quantifiable methods in developing software, because in the real world in this area, many developers are using their experience, their expert according to their experience, not by science, not by quantifiable metrics, something like that. So in this area, the researcher is trying to find some a method to how to explain, how to proceed this development life cycle using scientific methods. And the expert in this area is called software engineer. So in these five research area, the origin is this in the third, which is the computer science, is the origin of all of these area. And personally, my research is about software engineering mainly, but also I'm working about the computer science, because there are some area I've been working. It's about how to develop software in optimal way. there is one thing that I have been always wondering. We know that there are many engineering fields in other area. Yeah, mechanical engineering, civil engineering, and chemical engineering. But they are translated in Indonesia, which is called teknik kimia, teknik sipil, teknik mesin, something like that. But one only for the software engineering is translated in Indonesia is called Rekayasa Piranti Lunak. So for me personally, I don't agree with that translation because that rekayasa it's negative meaning, have a negative meaning, something like changing some data to make, yeah, really something like that.
Manipulation.
Yes, like something like that.
Statistical manipulation.
Yeah. So I rarely use the translation of this the RPL, the Rekayasa Piranti Lunak. So I prefer use this software engineering term. Okay. My study about software engineering, and I start this area from my bachelor. My thesis in bachelor is about how to structuralize, how to make the structure of the software by identifying the relationship between the function and the data. And I use some statistical method in there to how to make the decomposition of the system of the software by the information derived from the relationship between between the function and the data. And for the my master degree, I also studied about the structure of the software. Also, I've been studied about the software quality, especially about a method which is called quality function deployment, or QFD. I will explain about that later. The QFD is one of the method which is founded by a professor in Japan and has been acknowledged by many experts in academic and also in industry all over the world, especially in United States and European countries. Okay, before I explain about my research, I will try to explain about typical software development process. I believe that some of you have background in statistics, so I will make this in brief explanation. In typical way, the software is developed using these 5 phases. It starts with the requirement analysis, which conducted by identifying what the customer is really need, what the voices of the customer, and then these requirements, these customer requirements, will be into these requirements. And after we finish this design phases, we start developing the software by writing a programs, building a database, building a computer network, something like that. And after we finish this development, we start testing the software. And after that, the software will be released and used by the customer. And starting with that, the maintenance phase will be initiated. This process is called the waterfall model because it's look like a waterfall. This process only work in a perfect world. In the real world, it never works because from the previous study, the requirement is always changing. Like Miss Ari said today that yes, when in the PKL there is always change in the validation rule, even after the survey started. And yes, ideally, the requirements should be fixed before we start designing the software and before we start developing the software. But in the real world, it doesn't work like that. These graphs show the previous studies about this requirement change. It shows that it's always occur. It's always occur there. This requirement changing is called requirement volatility, which is defined as the growth or changes of requirements during software development life cycle or their requirements instability. These requirements volatility or this requirement instability is occur because of the diversity of the requirements by the stakeholders. We know the stakeholders is in PKL the students and the lecturers in the institution, also the BPS, also the PEMDA. Every part is the stakeholders of this activity. So if they don't have an agreement about this requirement, the requirement will be always changing. So we cannot avoid this requirement changing. That's one that now everyone, every expert in this software development should aware about that. And the problem is how to counterpart that problem. That is the challenge about that. And the approach is about to address this requirement volatility. There are two approaches. The first one is by identifying complete requirements so that there will be no change requests in the future. If we can elicit, if we can derive these requirements completely, so there will be no change request in the future. We can guarantee that. But in the real world, it's almost impossible. So the second approach is to anticipating this future changing by preparing for the change requirements, so that if we accommodating this change request, the impact will be low, the effort will be low. and the time for accommodating this changing should be in short time, not taking a lot of time. So according to this, my research is about the second approach, how to anticipate this requirement changing, how to prepare, how to design, how to develop the software, so that if there is a change request, the software can immediately accommodate, it can immediately adapt to that change. So in software, we talk about the requirement. Software should be developed to meet the requirement from the customer, and the software also need to be designed. So there will be some of the architectural design of the software. Here there are two things should be considered. There are the requirements and the architecture of the software. I think this requirement and the architecture of the software is somehow a trade-off relationship, because if we hear all of the requests from the customer, the architecture design will be not rigid, will be not good, will be a lot of hole in the architecture, because we put all of the requests from the customer in the software. It's like if we repair the broken road, if we repair the broken road, then we can see that the road is no longer smooth. Yeah. And the second one, if we focus on the architecture, if we build the software in the very rigid architecture, the consequences of building the rigid architecture is that we can no longer hear or accommodate the request from the customer. So there is one solution for this, which is called the framework or the development life cycle, which is called the Twin Peaks, which is a life cycle that acknowledges the need to develop software architecture that are very stable, but yet adaptable in the presence of changing requirements. So the architecture is very stable, but in case of the changing requirement, it still can be adapted. So my research question is it possible to estimate and identify which requirement have the potential to change in the future? By identifying which requirements have the potential to change, we can prepare for that. So we can make some a little loose architecture for the specific requirements which have a potential to change in the future. And the second one is it possible to anticipate these changing requirements and prepare for the countermeasure with low impact, with fast action, like something like that? And the methods I've been used is first, for the first question is called quality function deployment, which is called QFD, and RMAP. This is a risk assessment method. And for the second one, I used two methods, which is called the test-driven development and the acceptance test-driven development. The method I've been using in this research is first the case study. I have been conducting two case study, and also action and survey. I've been also conducting two a project of the development of the real world software system, and I was collecting data from the development of this project. In the next slide, I will explain about a brief explanation about this quality function deployment. Before I begin to explain, I will ask you one question. What kind of shape do you see here?
Circle and triangle.
Okay, circle and triangle. Anyone else? No? Anyone see that as a cone?
Yeah, if we combine it.
Okay, that's right. You can see it here. A cone, if we see from each side of this cone, we can see this as a circle, and we also can see this as a triangle. The concept of this quality function deployment, or this QFD, is how to see a system from multiple angle, from multiple view of, or multiple side of views. So this quality function deployment is a method to clarify the voices of the customer and define the product quality as well as the business functions for the product based on the voices of the customer, and take them into account in the whole development process. So if we see here, this process starts from the voice of the customers, and we can derive the requirements, and we can derive the quality of the requirements. For example, if we build a pencil like this. Example.
Last question before we move on.
Yes. Okay. Sure, please.
Well, just to clarify myself about what is going on, otherwise I'm really 100% lost. Okay. So, what do you mean by voices of customer?
Yeah, it's
Something measurable? Is a voice? What this term mean?
yes.
What does this term means?
It's about the customer needs.
Customer needs.
Yes.
In terms of what? Some sentences, some.
Anything. It's the raw voice of the customer. It's
The voice or the something the requirement?
Function of the system.
no,
The requirement.
Huh?
it's not only the function, it's also the quality.
The quality.
Yeah. It's a pro.
I require a system in such a way the distance between this can be achieved in 5 minutes, something like that. That's a kind of requirement.
Yes.
They call it voice of.
That's one of the voice of the customers, and we should hear what the customer
How
really
you measure
needs.
it then?
Yes.
How you measure it? It is a quality function deployment. This kind of model or system or structure. What is this animal?
Yeah. Yeah. You can see here
Because
that.
this is really outside my province.
Yeah. Actually, this method, or this method, start from the industry in Japan, because many industry in Japan, about 40 years ago, they are always having this quality test in the end of the process. process of building a product is starting from the analysis, design, implementation, and testing, and also from the inspection in the end of the process. And the quality control in the product in Japan start from inspecting the good product in the end of the process.
Could you give a simple example? Yes, a simple example. Okay, maybe vary or just
like
live example so you can understand. Real example.
Okay.
Live example. Okay. For example, you want to produce certain things, something like that.
Yeah.
This is not my area.
Yeah.
Bagaimana? You understand what he's talking about?
I will borrow.
Yes, maybe I asked to my students in Happy,
How the user easy to use the function on the questionnaire, the data questionnaire. So only for users to many click to the questionnaire. Automatically for submit the questionnaire to the server. That's some requirement, an example of user requirement to the developer. Okay, we are develop the Happy that has very easy for the user. It's a customer.
So the requirement is to have only one click of the button and send directly to the server.
But and also I need no need for click.
Sorry, ma'am, can you use microphone?
In one period that we.
I see. When you answer the question, yes, you have an interview and you have the laptop in front of you, and then you enter the answers and automatically.
this user
This kind of requirement.
That's kind of requirement. So the system will be very easy for the user. I think that's one example.
Like automatic save.
Automatic save.
Answers you enter,
Yes.
just wait the answers and automatically save.
Yes.
Yes, kind of requirement.
Yes. Automatic counting for some variables. That automatic counting. Yes. Thank you, Pak.
Yeah, please.
And the problem is how to measure that requirement. As like you said before, that how to measure the use easy to use or fast or maybe light. If we want to buy a ballpoint, we always have some requirements. Yeah, easy to use or very durable or something like that. Yeah, how to measure that? So this table, sorry, yes, this table is something like that. In the left side is the requirement. Sorry for this. Yeah, the left side is the requirement.
Okay.
Yeah, it is a sample for the match, the lighter. Yes, and in the top side is the quality characteristics. So for example, for the requirement ignite with one hand, so the lighter could be used only by one hand. The quality characteristic related to that requirement is the ignition pressure, the rate of the ignition in the move, and something like that. And then this in the industrial engineering, yes, and this quality characteristics, and then could be deployed to the real specification of the design of the product. How to manage the low pressure of the lighter. We could use any measure about that, maybe for using Pascal or something like that. And the rate of ignition, we can use how many time it could be ignite while we move, something like that. That can be converted into the quantifiable metrics using like that. So this table, which is called the quality table, in this quality function deployment of QFD, not only this table, there are many tables used in this. Most of them are the two-dimensional tables. So we can use this quality function deployment method to deploy the initial voice of the customers, which is then converted into the requirements, and then to the quality characteristics, and to the design, into the technical specification. And then we could trace from the initial requirement into the design or specific part of the product. That is the idea of this method. Does that answer your question?
Yeah.
Okay, thank you. Okay, I will proceed. And yes, according to that, I use this method to develop this framework. This
I have to follow the meeting. 2 meetings. I have 1 body.
thank you, sir. Yeah.
That one is also important.
Yeah. I developed this framework, which is the input is the customer requirements, and the output is the estimation of the volatility or the potential of change in the future of these requirements. And this is the calculation or the transformation tables. This is the customer requirement, and this is the software function. And then software function will be deployed to the architectural design elements. And according to the previous study, that the chance the request for changing of the requirements mostly occurred in the phase of the design. So if we can derive, or if we can deploy these architectural design elements from these customer requirements before we start the development, we could estimate. Yes.
Sorry, I expected. How we get the numbers?
Which number?
The numbers in the cells. 5, 1, 3, 4, 5.
It's just for illustration.
But in
Yes. The number represent the strength of the relationship between those elements.
How we get the strength?
The strength.
Yeah.
We can use this. Yeah, like this. Yeah.
Theoretically or empirically?
Yes.
You said that a strong relationship.
Yes.
This is theoretically or based on empirical?
Both. Both. The one who developed this product know how to implement. For example, how to implement the requirement for ignite with one hand. So what kind of quality characteristics needs? Yeah, and then they could assign this relationship, which
how we assign the number, the strong relationship, average, potential relationship?
Yeah,
Theory, imagination, or based on the empirical evidence?
which mostly from the empirical from the previous projects.
From the previous
projects. Yeah. Yes.
So from a number of previous projects or one project.
Numbers of previous.
From a number of
yes.
previous
project.
similar projects.
Similar, of course. Yeah.
Number of previous similar
projects. Yes.
So they can get
the strength. Yeah. The strength of the relationship between the.
Okay.
Yes.
Okay. It's very clear.
Yeah. So this composition of this table should be conducted by not only for the analysis or the customer, but also should be conducted by the designer, by technical designer. So they know how to build this thing. Yes. Okay.
Okay.
Sorry. Yeah. Then sorry. Yeah. So we assign these relationships, and then we can derive these architectural design elements needed for to implement these requirements, and then we know how from the empirical study and from the previous projects, we know which design elements have the high potential or low potential of changing. Yeah, something like that.
J, I, and A. The formula.
Yes.
I means what I stand for. I, J, and this
Yeah, this is PA is the
I.
degree of volatility. We start from here. Sorry. Yeah, the I is the index, and the AN is the number of the A is the architectural design. Architectural design is the A, and the number of the architectural design elements, and
N is number of agricultural design.
yes, architectural design elements
1 to AN.
for 1 to AN. Yes, and PA is the potential of changing or the degree of volatility of these architectural design elements, and yes, and FA is the relationship, yeah, between the functions and the architectural design elements. Yeah.
So I is a function, J is agricultural design.
Yes. Yes. And we can calculate or estimate this degree of volatility or potential of changing of the function, and then we can calculate back to the customer requirements, to the degree of volatility of the customer requirements. Okay, and how we define the degree of volatility of these architectural design elements? How we define, for example, the elements or the design elements for the data, the design elements for the user interface, the design elements for the logic. How we define this degree of volatility of each element? We use this method, the RMAP, which is the method for assessing the risk, and we use this method to define this degree of volatility. And we I have conducted a survey to the real world of development, software development, and I was collecting the number of changing, the number of requests of changing, and where which part of the software, which is the changes or modification have been conducted for the particular changing request. And from this survey, I have this number, the risk of change of this architectural design element. This number means that the change in the domain design element is the highest have the highest potential of changing, and the presentation have the lowest potential of changing. So we use this number to calculate, to estimate the degree of volatility of the customer requirements. And the case study I've conducted is by using this SPMB, seleksi sistem penerimaan mahasiswa baru SDS. I use this system and I derive these customer requirements, and the result is like this. And we can see here that the number show the potential of changing of these requirements. And by we analyzing this number, we can know which requirement have the potential of change in the future. So we can prepare to design the architecture of this particular requirement to be easy to change, to be easy to maintain. Okay, that's the first result for the first question, for the first result, research question. And the next is the second research question, is how to anticipating the requirement volatility. In this second question, I've been using this method, the test-driven development. This test-driven development, or TDD, have been practiced by programmer, which conducting or practicing the agile development life model. And in this test-driven development, I've been also doing some survey and also the action for the how to evaluate this method. And after conducting this survey, I have this result, which shows that the proposed method, which using this test-driven development, compared to this conventional method without using the test-driven development. And the number here is the maintainability index. The maintainability index represent how easy the software or the program can be changed, how easy the program can be changed and test. It shows the number. So the higher the number, the higher the easiness of the program to be maintained. So from this result, I can see that if we use this, if we apply this test-driven development method, we can have the program easy to manage, easy to maintain. Okay, that's for the second. And lastly, this is my last research, which is still need to be studied, which is collaborating the QFD and the TDD, which the first phase is the application of the QFD from the voice of customer to the requirements, to the function, and to the quality characteristics. And the second phase is doing the development of the software using the input from the result from this first phase, and conducting this development using the test-driven development. And the results the expected result is that we can develop a product, a software product, which is very highly maintainable, but also accommodating the voice of the customers. So I want to conclude this presentation, and the first one is that in the analysis and the assessment of the requirement volatility can be conducted using the QFD and the RMAP. And this is the answer for the first research question. And applying TDD in the development of the business system can improve the maintainability index, which enable the developer can easily modify the software even there are some requests of changing in the future. And yes, the last one, the development of framework by collaborating the GFT and TDD is also provided in the research, but is still needs a lot of work. My research have been published in some of the publication, which is in the conference and also in the journal, in the international journal. I also participating in the collaboration research with the professor in the University of Yamanashi, and there will be one paper is expected to be published in the end of this month. Oke, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you for Pak Anang for the presentation about the requirement volatility. And the point that we get from the presentation is the first one is the difference between the engineer and the scientist. And maybe we can position ourselves. We are scientists or engineer. Scientists will explore about the methodology, the basic methodology, and the engineer. It is about the multidisciplinary, combine some field and to find the best method for the some problem. And the next is the rekayasa is the problem because in the BPPTN Badan Penelitian, the engineer called in Indonesian word is prekayasa. The first time I hear the word is a little bit funny because the prekayasa, and this is officially in Indonesia, prekayasa, functional prekayasa. Okay, and about the content of the Pak Anang research, the common knowledge that we had because that the requirement is difficult to measure, but this is the strength of the science or the engineer that we can build the quality function development, and we can measure with certain calculation how to assess the product. Maybe another discipline can apply this method not only in the software engineer, for example in the survey methodology, and how to assess the methodology and measure the quality. Okay, next we will see the presentation from Bu Siti about clustering. And okay, please present the topic from Bu Siti Mariyah. Okay.
Assalamualaikum.